Hello students, how are you all doing? Hope that you must be fit and well. Today we are doing a sum from JEE IIT Entrance Advanced paper, okay, 2016. The sum reads like this. Let n be the smallest positive integer such that the coefficient of x squared in the expansion of 1 plus x squared plus 1 plus x whole cube plus plus 1 plus x to the power 49 plus 1 plus mx to the power 50 is 3n plus 1 to the power 3n plus 1 into 51c cube for some positive integer n. Then the value of n is. Okay. Now see here, what is the question saying? And the answer of this question is any number, integer ranging from 0 to 9. That means both including. Okay, from 0 to 9, any number is the answer of this question. And you have to tell what is the answer of this question. It is any integer from 0 to 9. Okay, and we have to find out that value. Correct? Now see here, first understand the question. What is the question saying? Question is saying that m is a smallest, okay, smallest positive integer. This is the smallest positive integer which is can be possible, smallest possible number, integer. Okay, that is positive, that is greater than 0. And here it is also given in the question n is a positive integer. Okay, and we have to find the value of n. We have to find the value of n, which will be a positive integer ranging from 0 to 9. Clear? Now here there is a some expression being given, and there is actually a sum equation being given. Okay, now see here, what is the sum say? There is a one expression like this. Okay, I am denoting that expression by capital letter E. This is the expression given: 1 plus x whole square plus 1 plus x whole cube plus like this. Okay, here it is 1 plus x to the power 4, like so on, up to here 1 plus, okay, it is up to plus 1 plus x to the power 49 plus 1 plus m x to the power 50. Okay, and it is being told to us that the coefficient of x squared in this expansion, the coefficient of x squared in this expansion value is given in terms of n. It is 3n plus 1 into 51c cube. So first we will find the coefficient of x squared in this expansion. Okay, now see how we expand a binomial expression. Now suppose here all are okay, now suppose a general binomial expression I am taking a plus b raised to any power, suppose n. So how we expand it? We expand it here. First we write nc0 a to the power n and b to the power 0 plus next term nc1 a to the power n minus 1 b to the power 1 plus nc2 a to the power n minus 2 b to the power 2, like so on. Okay, like this going on up to the last term. Okay, last term will be ncn a to the power 0 b to the power n. Okay, now see here the binomial coefficient here is here it is the b power 0, then it is nc0. Here it is second term power. Whatever is the second power, the binomial coefficient is that. Here it is b to the power 1, then it is nc1. Here it is b to the power 2, it is nc2. here it is b to the power n, then it is ncn, and so on. Okay, now here the second term is given here up to x to the power 49, 1 plus x to the power 49. The second term here in all these expressions, the second term is x, and here the second term is mx. But the first term in all the expressions, the first term is 1. So 1 raised to any power will be 1 only. Okay, so the coefficient of, so therefore the coefficient of x squared, so the coefficient of x squared will be what in the whole expansion in E. Okay, so that will be the binomial coefficient added up for x squared. Okay, so what is the binomial expansion binomial coefficient of first one? It will be 2c2x. Okay, because it will be x squared, so 2c2. Here it will be 3c2 for the second one. Okay, and because the first term is 1, so that will be 1 squared will be 1. Okay, so here it will be, so here it will be 1 to the power something, it will be 1. Okay, and the coefficient of x squared will be 2 to the power 2c2, here it will be 2c3, here it will be, okay, here it will be 3c2, here it will be 4c2, next will be 5c2, and so on up to 49c2. Okay, and for this, what will be the coefficient of this x squared or x squared? So this will be 50c2 into m squared, because this will be mx whole squared. So the coefficient will be m squared also, 50c2 into m squared. Okay, now see here. So this is the coefficient of x squared in the expansion. And here the important formula that is required. Okay, see here, what is the important formula that is required? Here you have to know that, okay, formula for the binomial expansion, this is NCR plus NC R minus 1. Okay, NCR plus NCR minus 1 is equals to N plus 1 CR. This is the formula will be needed. Okay, now see here. Here 2C2 is what? 2C2 is 1. That is same as 3C3. 3C3 is also 1. So in place of 2C2 I can write 3C3 because both values are 1. Okay, so here see here. Here I can write here for this I am now finding out the value. 3C2 plus 3C, 2C2 plus 3C2. In place of 3C2, 2C2 plus 3C2. So for 2C2, I can write it as 3C3 because both the value are 1 plus 3C2. So what we are seeing here? Here in n is here both are 3 and here it is r value, here it is 3 and here it is 2 minus 3 minus 1, that is 2. Okay, so what will be the formula, what will be the value of this? The value of this will be n plus 1 CR. So n is here 3, so 3 plus 1, that is 4 CR, that is 4C3. So the value of this will be 4C3. Okay, so 4C3 will be the value of these two terms. Okay, so this will be 4C3 and I am now adding this with it. Okay, so 4C2. So now you see here, here in place of n, here it is 4. Okay, and here it is 3 and 2. So here it is r is 3 and here it is r is 3 minus 1. So what will be the value of this? The value of this will be n plus 1 CR. R is 3. So n is 4. So n plus 1, that is 5C3. So up to here we are getting 5C3. So like this, if we will continue like this adding up, up to here for 49C2. Okay, so up to 49C2, if you will continue adding like this, you will get, okay, 50C, okay, 3, you will arrive up to here. Okay, up to here, if I will add from here to here, it will, the value will, you will get 50C3. Okay, plus I have to add this also. So that will be the coefficient of x squared in this expansion. So this will be 50C2 and squared. Clear? Now see here. Okay, so this will be the coefficient of x squared. Okay, in this expansion. So now I am, what I am, see, you will express this 50C3 plus here n squared. You write it as, okay, n squared, you write plus 1 plus n squared minus 1. So 1 I have added and 1 I have subtracted. So result will be the same, n squared. Okay, so what we will get by expanding it? So this will be 50C3 plus 50C2. 50C2 into 1 will be 50C2 plus it will be 50C2 into n squared minus 1. Okay, now here also apply the same formula. So in place of here n value is here same 50. Okay, and here it is 3 and here r value is 3 and here it is 3 minus 1, 2. Okay, so the value of this 50C3 plus 50C2 will be 51C3. Okay, n plus 1 CR. Okay, and this will be n squared minus 1 into 50C2. So this is the coefficient of x squared in the expansion of this. Okay, so that is equals to 3n plus 1, 51C3. So equate this coefficient of x squared with this. Okay, so now I am equating. Okay, now see here. So what we are getting from here, we are getting that this is the coefficient of x squared. So this is 51C3 plus n squared minus 1 50C2 is equals to, in the sum it is given, this is equals to, the coefficient is equals to this. So equate with it. So that is, okay, so that is equals to here 3n plus 1, okay, into 51C3. Clear? Now see, now here expand the right hand side. Okay, now expand the right hand side. So what we are getting from here, okay, so this is 51C3 plus n squared minus 1 into 50C2 is equals to 3n into 51C3 plus 1 into 51C3. So 1 into 51C3 will be 51C3. So 51C3 is this side, left hand side also, and 51C3 is in the right hand side also. So cancel from this, both the sides. So what we are getting? We are getting n squared minus 1 into 50C2 is equals to 3n into 51C3. Okay, so what is the value of 50C2? So see here, n squared minus 1 into 50C2 means 50 into 49. Start from 50, write 2 terms in the means consecutive terms in the decreasing order. Okay, so 50 into 50, 49 divided by 1 into 2. So this is equals to 3n into 51C3 means what? 51 into 50 into 49 means 3 numbers you have to write in the descending order, starting from 51, and here divide with 1 into 2 into 3. Now see here, 3 and 3 is cutting from here, and here it is 1 into 2 in the denominator in the left hand side and 1 into 2 denominator in the right hand side also. So we can cancel from here, from both the sides, and 50 is here in the numerator 50 is here in the numerator, so you can cancel from here. 50 50 and 49 49 also you can cut. Okay, so what is the remaining we are getting? We are getting is this m squared minus 1 is equals to 51n. Now check, now what we will get from here? M squared is equals to 51. Okay, so from here we are getting 51n plus 1. Now we will put the different integers here n. We have to find the value of n satisfying this equation. M is the smallest positive integer and n is the positive integer. Okay, now we will put different values of n so that here we are getting a square of some positive number. Okay, so the value of 51 into n plus 1 should be a square of some positive number. So we have to find that. Okay, now see here, we will try now by putting different values of n one by one. Okay, in positive integers. So here this is the relation between m and m is the smallest positive integer. Okay, so right here, so here it is m squared is equals to 51n plus 1. So I am checking with starting with 1. So let the n value will be 1. So right hand side will be what? Then here 51n plus 1 should be a square of some positive number. That will be means the smallest positive number. Okay, now here I am putting n value 1. So what will I get? 51 into 1 plus 1 in the right hand side I am putting. Okay, so here it is 51 into 1 is 51. 51 plus 1 is 52, which is not a square of any natural number. So n cannot be equals to 1. Okay, so here then check for n equals to 2. So when I am putting n is equals to 2, what I am getting here, in place of n you put 2 plus 1. Okay, so 51 into 2 is what? 102 plus 1, that is 103, which is also not a square of any positive number. Okay, then this n cannot be equals to 2. So then put n is equals to 3. So when I am putting n is equals to 3 in the right hand side, so what will I get? 51 into 3 plus 1. So 51 into 3 is 153 plus 1. So that is equals to 154, which is also not a square of any positive number. Okay, then here then put n is equals to 4. Okay, this should be a square of a positive integer actually. Okay, so here I am putting n is equals to 4. So putting the value of n equals to 4, so right hand side will be what? 51 into 4 plus 1, which is equals to 204 plus 1, which is equals to 205, which is also not a square of any positive integer. Okay, then you check n is equals to 5. Okay, so RHS will be what? Here 51 into n value I am putting 5 plus 1. So this is 5 and this is 255 plus 1, which is 256, and 256 is the square of 16. So which will be the smallest positive number? M is the smallest positive. There may be many numbers, but we have to stop where m is the smallest positive integer. Okay, so here we have arrived that it is equals to 16, which is 16 square 256. So the n value is equals to 5. Okay, so n value is 5. So that is the answer. Okay, so I hope that you must have understood the sum very clearly. Okay, thanks for watching the video. Stay fine. Thank you.